Next one's going to be Tycho Anderson from Cisco talking about forwarding syscalls to userspace.
Hello, everyone. My name is Tycho Anderson, and as Stefan said, I work for Cisco. I've worked for a few different places recently. Also, people usually have a picture of themselves on GitHub, but my GitHub picture is like 6 years old, and I didn't have a beard then, so it doesn't really look anything like me, so I didn't think that would be very useful. Anyway, what I'm going to talk to you about today is a little kernel patch set that I worked on recently called, that basically enables you to forward syscalls to userspace. So what does that mean? So for motivation, if I do an unshare and I'm in a user namespace and I try and do a make node, I'm not allowed to do that. For those of you who are familiar, 1 and 3 are the device major minor for dev null. And that seems sort of unreasonable because dev null is a fairly harmless Linux device which just sends EOF. And if you look in the kernel code somewhere, there's this check basically, which is this, and the important part is this capable bit. So there are devices like dev-kmem or dev-mem, which are you would not necessarily want to let a container have access to because then people can do bad things. But in the dev null, dev zero, these kind of innocuous devices, it might be nice to relax this restriction a little bit. So one option would be to hard code a list of acceptable devices in the kernel, in the BFS make node layer, and then move on with our lives. But then every time somebody adds a new device, and you have to argue with the maintainer of that device about is this okay or not, yada yada. So another problem is you can't mount certain file systems. So the Ubuntu kernel actually has some patches that are out-of-print patches that there's a sysctl where you can enable mounting of X4. There's a flag, it's fs_user_ns_something else, I forget what it is, in the kernel that indicates whether or not a user can mount a file system. But the reason these restrictions exist are mostly because the file system parsers aren't safe or whatever. And some of the maintainers, like Ted Stubb, an X4 maintainer, has said, hey, I'll fix weird file system parser bugs that cause exploits. So some of the file systems might be safe. So maybe that's something you'd be interested in doing. And basically, it sort of has the same check here. You must be root and have the capsysadmin capability to do that. So what if we could instead do something like this? And the network's bad, so I had lax animation, but we'll just use a PDF so that it doesn't die. So anyway, if I start in the container, and the container runs a mount syscall, that would go into the kernel through the regular entry path, and then do some magic function, and then forward that to the host, which could then set an S to the container's namespace, do the mount, assuming it approved things, and then lie to the container and say, hey, your mount call succeeded. It didn't really run the mount call in the context of the container, but we did it for them, we lied to them, and it all worked out. So you can imagine doing this with mount or with make node, or loading kernel modules. So ordinarily, you would not want to let a container load a kernel module because then all of a sudden they're running code in the kernel. But there is this thing where it's actually maybe reasonable to look at the module blob that the container is asking you to load and then load the host version. Because in particular, the kernel that the host is running may be different than the kernel that the container was running. So even if it wasn't malicious, it still might be incorrect. You wouldn't be able to load that module. But if you're trying to load the IP tables module or whatever, as long as you load the host module and it exposes all the APIs that the IP tables thing exposes, then it should work just fine. So this is a way that you could allow kernel or containers to load kernel modules, assuming that you had a safe version that you actually trusted that was on the host. So this is like another application of this. You can imagine there's a whole bunch of these. where it would just kind of be nice to have an implementation of this magic function here. So how do we implement magic? So the easiest way is with ptrace. And this, you can do this today. And in fact, if you look at the checkpoint restore tool, the live migration tool for containers, they do a lot of this stuff, but actually GDB and every other thing, they do this stepping where you attach to some task, you step through syscall by syscall, you look at whatever the arguments are, you process them however you want. Of course, the problem with this is you have to stop on every syscall. And so that gets slow, and most of the syscalls you don't care about. You maybe only care about mount and an init module, which are fairly uncommon, and the rest of the thing you want to just run forever. So there's a second way, actually, still using ptrace, where you can use seccomp. And basically this is like the assembly code version of BPF. But the important part here is the seccomp ret trace. Basically what this says is, if you see a mount syscall, trigger a ptrace event. And so then you can ptrace attach to a task, and it runs along normally, not stopping at every syscall. But then when the seccomp program says, hey, something happened, then it triggers a ptrace event, and you can be listening for that. So this is a lot faster because you don't have to stop on every syscall and make sure it's the one you're looking for. But it still means that you have to ptrace the task. And so if I'm a container runtime and I'm trying to implement this line to containers about what their syscalls are returning, that means I have to ptrace them. So then when the user comes along and wants to debug that, what do they do? If they want to debug, well, they use the Feynman algorithm, which is write down the hard problem, think really hard, and then write down the solution. And that's not really ideal. What you'd like to be able to do is use strace and GDB and all these other tools that you're familiar with. So what we'd really like to do is implement something that doesn't involve ptrace. And so that's basically what this set does. So we have, instead of doing a seccomp ret trace, we can sort of introduce yet another seccomp return code, which is return user notification. And that basically would trigger this magic to happen. And then how you would interact with that as a programmer who's on the other side of that is, it's basically, at least in the implementation that I posted, it's just a file descriptor. And so you have two things. You have a notification. The kernel sends you this structure. You have an ID, which is like just a cookie. The process ID of the task that did this, and then the seccomp data. And if you look at this, it's the same structure you get, for like your eBPF program that you have, or your BPF program here. This struct seccomp data, you get basically the same data. And this is important because this seccomp data structure does not expose stuff like actual memory of the process. So for example, for the mount system call, you actually pass it the name of the file system and the source and target locations that you want to mount at. You pass those as pointers. And so in the kernel, the way syscalls are implemented, they're not atomic. So for example, if the seccomp policy runs first thing right after entry, it might read some pointers, check the memory, say, okay, this mount seems reasonable, we're just mounting here to there. Those are both not important paths. And then, it says, okay, go ahead and do the syscall. But then when the VFS layer actually reads this, if you change that value via another thread or somehow with shared memory or something, then the seccomp filter already said it was okay, but now you changed it as something nefarious, so there's a time of check, time of use problem here. And so that's why seccomp traditionally does not expose the task memory to programs. And so you might think, okay, well, don't you have the same problem here? And the answer is yes. You have to be a little bit careful about how you do this. So the magic trick is there, if the task has some shared memory with another thread or something, and it's that can mutate its address space, it can change the memory for that task. But if you, as the tracer or the person who's doing the mounting or whatever on behalf of this task, if you copy all of the relevant memory out, and then inspect it all on your side, then it's an atomic thing, because they can only edit their memory, they can't edit your memory. So whatever the initial value of the syscall is, that's what they're going to show you, and then you can apply your policy and say, yes, this is an OK mount, or no, this is not an OK mount. So with a little bit of cleverness, you can actually work around this other time of check, time of use issue, which Seccomp has. So anyway, that's what the notification looks like. So you basically, you read from that, on here on the right side, you read from that, then you do whatever the stuff you're going to do is, and then you respond, and you can respond with an error code, and you respond, and that's all well and good. As you might imagine, do stuff is slightly complex, so there's the time of check, time of use issue that I just mentioned. There's also this problem about actually accessing the memory is just itself a complicated, or somewhat complicated problem. You basically, /proc has these files called map files where you can open some other task memory to mmap that and then read whatever addresses you want. Or you could, if you really like pain, you can use ptrace peek and poke user. But those are not super awesome to use. And then there's actually a third problem, which I sort of haven't discussed. If you're doing this with, I'm going to fake opening netlink sockets for you or something, you can imagine doing all sorts of crazy stuff with this. But in that case, the system call actually returns a file descriptor, and you need to inject then that file descriptor back into the task's address space, because if you open a file descriptor here, it's got to go there somehow. And so there's a number of ways to do that. Basically using ptrace, you inject some code that then does a receive message on some file descriptor or something. You could inject the code that just opens the file descriptor from somebody else's /proc if it's actually viewable. Or a potential extension to this set is we could add a way to do this very nicely from the response structure, which may or may not be interesting. We'll see how this whole discussion goes in the first place. So then there's a question of how do you get a hold of one of these things. So I told you read and write with this file descriptor. So this is also sort of an open question. If you have an API design that you think is cool, come talk to me. Right now I have sort of two different ways to do it. The first one is you install a Seccomp filter as you normally would with the Seccomp syscall, but you pass this additional flag, and then you get the FD back, and then you can message that FD to some server or whoever, and then that server will subsequently rewrite, pull, do whatever. Of course, the problem with that is if your Seccomp policy blocks send message, then you can't do anything. So that's not really ideal. Another way would be to use ptrace again, but you can attach to a task and get a listener for one of its Seccomp programs, and then you don't have to send messages. You don't have any of this weirdness, but you do have to use ptrace to do that. So some people don't like ptrace. So I think if you have another API design that sounds cool, I'm happy. This isn't really that hard to implement. There's some implementation issues, synchronization across tasks, because you're passing these messages back and forth between tasks is somewhat challenging. It took me a while of sitting and thinking to figure out how to do it. I think it's right, but maybe it's not, so come tell me I'm wrong. There's another issue about synchronization with an expired ID that's sort of a detail. Status, there's GitHub. We discussed it at Linux Plumbers, which is sort of the genesis for this idea, and then it's sort of sat on the shelf for 6 months, and so that's why I implemented it. I posted V1. Those of you who are very astute will notice that URL is today. I posted it this morning. So there's not a lot of discussion there yet. Join in. You could tell me I'm wrong. I was going to do a demo, but I only have 5 minutes, so I'll do this. I'm a polite person, so what did I just do? Yeah. I think my SSH session in my VM died, or the VM itself died. 415 kernel for me on this VM. This machine is not super awesome. So anyway, screw the demo. I wasn't really going to do it anyway. Do anything cool. Thanks. If you have any questions, I'm happy to answer them.
Questions?
So the obvious use case is to implement your capability security check. But say we would say use it to implement implementation and reuse the kernel's permissions check. Like, because that would be I control this with kernel, comes back to user space, I then want to use kernel again to check permissions, and then come back to user space, back into the kernel, as a result, back into the original program.
So you want to use the kernel to check the permissions of the task that you're tracing. So that information is mostly exposed through like proc self-stat and other things, so you can tell what capabilities.
But would you need to implement the logic from the kernel or which capabilities is required? And
if that's the logic you want, yes. So you can imagine lots of other things. The idea, I think, here is really to relax the constraints a little bit. But container orchestrators have a lot of insight that I think the kernel, just as a general rule, doesn't. And so the idea here is to sort of exploit that. We can allow containers to do more things, but still be secure. Although somebody pointed out to me that the syscall, is this a valid syscall code, runs after Seccomp. So you could actually use this to implement new syscalls. So I think the applications is sort of, if it gets merged, it's going to be a little bit weird. But, other questions? Nobody? All right.
Thank you.